Right, is x squared over 2 a polynomial? When you look at the variables powers, are the variables powers whole numbers? The variable is x, this power is 2. Is that a whole number? Yes. So this is a polynomial. Right? The coefficient can be a fraction. The coefficient can be a negative. In order to determine whether it's a polynomial, you look simply at its power. Is the power of the variable of a whole number? If yes, you have a polynomial. Okay, what about 1/2 x? Is this a polynomial? What's the power of the x? 1. Is 1 a whole number? Yeah, there's your test. So 1/2 x, again, the coefficient can be a fraction, okay, as long as the power is a whole number.
So the monomials count as polynomial?
Yeah, so a monomial is just a polynomial with a single term. Yeah.
But poly means
Well, poly means all of these categories fall within the polynomial. Yeah. So like if you said a polygon can be, as long as it's enclosed, you have, again, doesn't matter how many sides. Okay, as far as this next term, 2 to the minus 1 times x, is this an example of a polynomial? Is this a monomial term? Okay, what's the power of the variable? 1. Is that a whole number? Yeah. Okay. Really, what's the difference between these two terms? Is there one in the value? No, it's the same thing, right? Just different way to express it. The power of -1 just moves this 2 to the denominator. So these are exactly the same terms. Okay, they're both polynomials. What about this one? Now this is an exponential. It has a variable in the power, and so that is not a polynomial. You can't have any variables in the power. They have to be whole numbers. And what about this next example, 2 over x? If you were to think of this x up in the numerator, it would be 2x to the minus 1. Is minus 1 a whole number? No, so that one's not a polynomial. What about the square root of 2x? Again, you're looking at the square root of 2 times x to the 1/2. If you're thinking in terms of rational power, is 1/2 a whole number? No. So the first 3 are polynomials. The last 3 are not polynomials.